Hey everyone. Well, today's lesson, we're going to do lesson 2 and lesson 3 in this one, but today's lesson, lesson 2, is about money. So the lesson actually gets more involved into simple interest and compound interest, but we're going to just focus on compound interest for this lesson, partly due to time. And yeah, so simple interest, just to mention that, is when you simply find the interest at the end of a term and then you give the interest to the investor, right? If you invest money. Compound interest is where you invest money and then after a certain compounding period, the interest is evaluated and put into the same account with the original principal. And so then for the next period, you get interest upon your original principal and your interest, basically. So compound interest, interest upon interest. So things tend to grow a little faster in that regard. Actually, things grow exponentially. So we're going to go to the compound interest formula. Okay, so this page, and we're going to look at some examples after we talk about the formula. Okay. Okay, so here's our formula that we're going to use to calculate compound interest. All right, where A represents the final amount and P is the initial amount or the principal initially invested, and I is the interest rate per compound period, and N represents the number of compound periods. Okay. So I is not always the annual interest rate. That's why you have to evaluate it per compound period. N doesn't necessarily mean the number of years, so it's the number of compound periods or number of compound periods over so many years. All right. So yeah, we're going to take a look at this. This formula is not given on your formula sheet, but it basically is an exponential function, and it works a lot like your y equals a b to the x kind of thing. Okay, so let's take a look at a little bit of this. So example number 2, $1,000 is invested for 5 years at an annual interest rate of 6%. Complete the table to calculate the final value of the investment if interest is compounded according to the period of time. So we're going to switch up the how it's compounded, and you guys can see how the formula changes as a result. So if we're compounding annually, the number of compound periods per year would just be 1. And over a period of 5 years, that would make the total number of compound periods 5, right? 1 per year. Interest rate per compound period, well, they give us an annual interest rate of 6%. So writing that as a decimal, that'd be 0.06. Per compound period, well, it's annual anyway, so that wouldn't change, so 0.06. Your formula, therefore, would be A equals P. What was our P? 1,000. So 1,000 times 1 plus our interest rate, 0.06, to the exponent of 5, our number of compound periods. Okay, so this is P, 1 plus I to the N. Okay, and the amount, we can figure that out. If you want to grab your calculator and do that as well, and I'll do it, and we'll see if we get the same number. Okay, so we should have gotten $1,338.26. We round it to the nearest hundredth here because we're dealing with dollars and cents. Okay, semi-annually, how many compound periods would that be? That would be twice, or 2 per year. So over a 5-year period, that would give you a total of 10 compound periods, 2 per year times 5 years. Our interest rate per compound period, we would take our 0.06 per year interest rate and divide by the number of compound periods per year, so that would end up being 0.03. Alright, so our formula would become 1,000, 1 plus 0.03 to the exponent of 10. Okay, and we'll get that number. Okay, so we should have gotten 1,343.92. Okay, that's looking interesting. See if you guys can figure out quarterly and monthly. I'll fill the two tables in, and I will do that as well. quarterly, just as a hint, there's 4 quarters in 1 year. Okay, so see if you can get the rest of those filled in, and we'll check back and see if we have the same answer. Pause your video. Okay, how do we do? Check the table, and if you need to pause your video to check all the numbers, that would be fine. Let me just make a note here. We have, you'll notice the amounts, even though we started off with $1,000 invested for 5 years, the more often we compounded the same amount of money invested, the result at the end of 5 years was the greatest with the smallest compound period, or the most number of compound periods per year. Okay, so moral of the story is, the more often you're compounding, the more your money is working for you, as in the more money or interest you would create. Okay, let's look at example number 3. $7,000 is invested in a 6-year GIC, Guaranteed Investment Certificate, compounded quarterly. Okay, so that means our N is going to be 4. 6 years, that's related to the N, but we'll have to multiply that by that. Oh, sorry, that's not N. So quarterly, here, let's come down here. 7,000 initially invested. Okay, that's our P. Our interest rate, did they give us that? Yes, they did. It's 0.05, and that's per year, but we want per quarter, so we're going to divide that by 4. Okay, N is the number of compound periods over the 6-year period, so that'd be 6 years times the number of compound periods per year, 4, and that'll give us 24. And it looks like A is what we're looking for. So let's put that in our formula, and we would have 7,000 for P, 1 plus I, we could just leave it as 0.05 over 4, to the exponent of 24. Okay, put that in the calculator. Let's see if we get the same answer. Okay, so we've got it in the calculator. We're going to hit enter. Make sure you have the same thing that I do. We should get $9,431.46. So 9431.46. I do believe that was right. Yes, it was. Okay, and a little dollar symbol. And that's $7,000 grew to that over a 6-year period. Okay, let's look at the next example. Okay, example 4. Christine invested $2,500 for 4 years, compounded semi-annually, and received $843.26 in interest. What was the annual rate of interest? Okay, so that is connected to our I, not directly, but because I is our interest rate per compound period, so we'll have to change it to the annual after we get it. And let's see what else we have. A, okay, we have 2,500 is P, that's the amount initially invested. Our number of compound periods, we have compounded semi-annually for 4 years, so that'd be 4 years times twice per year, so 8. And A is our final amount. So A would actually be 2,500 plus the 843.26, not just the 843, because that's only the amount of interest that you earned. She still got the 2,500 in there as well. Okay, so let's set it up in our formula. Alrighty, so A is going to be 3343.26. I added the 2,500 and 800 and some, equals P, 2,500, and then 1 plus I to the exponent of 8. Okay, now our goal here this time is to solve for I. You'll notice I is right here, so first thing we would peel away from the left side is the multiplying, so the 2,500. So we would divide both sides by the 2,500, and we would now only have 1 plus I to the 8th on the right hand side. Okay, now we need to get rid of the exponent so that we can get at the I inside the brackets. So to get rid of this exponent, we are going to do the reciprocal exponent. Okay, we do not log both sides because we're not trying to find the value of the exponent. We're trying to find the base of the power, right? So we want to get rid of the exponent by doing the reciprocal exponent, because 8 times 1/8, that's just 1. Okay, so now we're down to all of that to the 1/8. Let's go ditto equals 1 plus I. So final step, subtract 1 from both sides. So here's what we're going to be putting into the calculator. I would be 3343.26 all over 2500 to the exponent of 1/8, and then all of that minus 1. Okay, so let's grab the calculator and get that number. Okay, I just want to point out what I typed in the calculator here. It's very important that you put your exponent of 1 over 8 in brackets, because if you don't, if you just go exponent 1 divided by 8, then it only does that to the exponent of 1, and then it divides the entire thing by 8. So you do not want to do that, so make sure you write it like this. And when you do, you should get that. So we're going to write that down, 0.037. Okay, so I would equal 0.037. We might need more decimals. We'll just wait and see here. Okay, now annual rate of interest. So this is the interest rate, so it would be 3.7%, but that's per compound period, so it's per semi-annual period. So to get that per annual, we would have to go, or per annum, we'd have to multiply that by 2. So we would have 7.4% per year, or per annum. And there we go. Good. Let's look at the next question. Barbara invests $8,000 in an account which pays compound interest of 6% per annum, compounded monthly. How long would it take in years and months for her investment to double in value? Okay, I want you guys to take a stab at this one yourself, at least to the point of where you've set up the equation, and then we'll talk more about where to go after that, okay? So try to set up the equation, get all the numbers in there, as many as you can, and then we'll talk about how to solve it. Pause your video. Okay, so everyone should have this set up. Please note when it said double in value, that is basically telling us that our final amount A would be double what we started with, which was 8,000, so that would be 16,000. So we should have these numbers plugged in. Now our goal is to solve for n. The first thing we'd get rid of from the right hand side would be the 8,000, and we would do that since it's multiplying going on. We would do that by dividing by 8,000, and we would get 2, and then we have 1 plus, and that number, if we put it in the calculator, 1 plus all that, would be basically 1.005 to the exponent n. Okay, that looks a lot easier. Now this time we're trying to solve for the exponent. So to get at the exponent, we are going to log both sides. And since we want to use our calculator, we're going to choose base 10 on our log. Okay, so we do that. Now our exponent can come down front, and that was the whole purpose in doing that. And then we can divide both sides by log 1.05, sorry. And off to the calculator to find out what n is going to be. Okay, so we should have gotten approximately 139. Now that is not years, okay? That is the number of compound periods, which, since we were compounding monthly, means that this is in months. So to get the number of years, we would basically go 100 and let's round it up to 139 months, and we would divide by 12 months in 1 year. Okay, and let's see what we get when we do that. So we would get 11 years for sure, and then we've got 0.58, so I'm just going to take away the 11 part, and then multiply by 12 again to figure out how many months that would be, and that would be approximately 7 months. So 11 years and 7 months. Sorry about that. 7 months. And there we go. Okay. We'll take a quick look at the example 6. Okay, borrowing money. So you can use this equation as well for borrowing money as long as you only pay the loan off at the end of the loan and not making regular payments. You can use the formula. I want you to try it, see if you can get an answer, and we'll check back and see if we have the same thing. Pause your video. Okay, as we're running out of time, pause your video if you need to check out my answer in more detail. But essentially we got 10 quarters, or which turns into 2.5 years, it would take to the length of the loan.
Okay, great. So next lesson in a new video. We'll see you then.